What's up, fellow polymaths? In this video, the Java Fundamentals tutorial, we'll be going over the collections framework. Collections in Java are a framework that enable you to store and manipulate a group of objects. Collections are able to achieve operations such as searching, sorting, inserting, manipulating, and deleting elements. The collection framework contains many interfaces, such as a set, list, and queues, as well as classes and methods. Vectors, stacks, and queues have been supplanted by more efficient collections, such as lists and sets. The java.util package contains all the classes and interfaces for the collection framework. In the collections framework, the iterable interface is the foundation interface for all the collection classes. The collection interface extends the iterable interface. Subsequently, all the subclasses of the collection interface also implement the iterable interface. So you can think of this as a grandparent-parent-child relationship, with the iterable interface being the grandparent, the collection interface being the parent, and then all the classes that implement the collection interface being the child. Here's a simple diagram of the collections framework. The ones marked in blue are interfaces, and the ones marked in green are classes. So at the top, you have the iterable interface, followed by the collection interface, which implements the iterable interface. And then after that, you have branches with the list interface, the queue interface, and the set interface. Remember, we mentioned that the queue wasn't really used much these days, and they've been supplanted by the lists and the sets. So within the list, you have subclasses that implement that list interface, such as Arraylist, a linked list, and so on. And within the set, you have the hash set and the linked hash set. The collection interface contains a bunch of methods, many methods that you'll be frequently using when you need to use collections. There are a lot more methods than what's on this list, but here are some examples. You have the add method that adds an element to the collection. You have the remove method that deletes an element from the collection. The remove all deletes all elements from the collection. The size method gets the number of elements in the collection. The clear method removes the number of elements from the collection. And the isEmpty method checks if the collection is empty. And we'll be going over these methods very briefly. So as we mentioned before, the Iterator interface is at the top of the hierarchy of the collections framework. It provides the ability to iterate through the elements in a forward direction. So you can think of iteration as looping through, like how we use the for loop or the while loop. There are three methods in the Iterator interface. There's a hasNext method, which returns true if the iterator has more elements in the collection, otherwise it returns false. There's the next method, which returns the current element and shifts the index to the next element. And then there's a remove method, which removes the last element returned by the iterator. The list interface is a child interface of the collection interface. So this interface possesses a list type of data structure, which enables the ability to store the ordered collection of objects. Lists are able to have duplicate values. And two of the most popular classes that implement the list interface are the Arraylist and the linked list. Since the list interface is a child of the collections interface, it also attains the method that belong to the collections interface, such as the add method, the clear method, the remove method, and so on. And below are some examples of being able to create a list object. So it's pretty much similar to how you create any other object with the few key differences, and I'll show you briefly how you can do that. The Arraylist class implements the list interface. The Arraylist uses a dynamic array to store elements of different data types, and this allows it to be a lot more flexible than a regular array, which only stores a fixed amount of elements. Arraylists maintain the order of insertion and is not synchronized. And not synchronized basically means not thread safe, and we'll be going over threads in a later tutorial. The elements stored in an arraylist can be randomly accessed. The drawback is that this makes Arraylist slower to access the elements. Along with the inherited methods from the collection interface, Arraylists also have useful methods such as the sort method, the get method, the set method, and so on. The linked list class also implements the linked list interface. The linked list uses a doubly linked list to store the elements. Linked lists can also store duplicate elements. Pretty much any list can store duplicate elements. Linked list maintains the order of insertion and is not synchronized. When you think of linked lists, you can think of, for example, the blockchain. How a blockchain is based on the order of the transaction that's received. And each transaction that comes up next gets added into that list. And when you scan the whole blockchain, the blockchain has to start from the beginning of the list up to the end of the list, and that in the order of the transactions that were received. Now that we have a brief example of the collections interface as well as the list interface. Let's try out some of these examples in the code. So the first example I'm going to do is create an array list of fruits, and then we'll iterate over those fruits. All right, so I created an object called list of fruits that's an array list, but it looks like the compiler is telling us that we need to import the array list class, so I'll do that right now. All right, I imported the array list class. I also imported the list class as well. So let's add in some objects for the list of fruits collection that we have. All right, so I added 6 elements into the list of fruits collection. So now that we have this, we're going to iterate over these fruits using the iterator interface. All right, so we created our iterator that will be used to iterate over the list of fruits, but we have to import the iterator interface as well. All right, so we imported the iterator interface, so now we can just run a simple while loop to iterate over those elements in the list of fruits. We've added the while loop, so now we can just run the program and see what happens. All right, so we got our output. We got the apple, banana, cherry, dates, then apple and cherry again. So pretty much what we added into the array list for the list of fruits object. Linked lists work very similarly, so if I change this to a linked list, for example. All right, so now that I've changed this to a linked list, I'm just going to run the program again, and we get the same result. So this is a quick example of how to add in elements to a collection as well as iterate through the collection. Okay, so as far as comparisons between array lists and linked lists are faster because no sorting is required when searching through the list. You can think of a linked list as a chain and an array list as a long line, with people entering the line from different sections. Array lists work best when storing and retrieving elements, and linked lists work better for manipulating elements. So in the future, when you're thinking of whether to use a linked list or an array list, you want to create a list that's made to just store and retrieve elements, then use array lists. Whereas if you plan on manipulating elements in a list, then you want to stick with linked lists. The set interface is a child of the collection interface. The set interface represents the unordered set of elements which don't allow for storing duplicate elements. Because sets don't allow duplicate elements, only one null value is allowed in a set. The set interface is implemented by various set classes such as the hash set, the linked hash set, and the tree set. And the way that you create an object from the subclasses of the set interface, such as a hash set or a linked hash set, is very similar to the way that you create an object using an array list or a linked list. The hash set class implements the set interface, and it uses a hash table for storing elements. Hash sets contain only unique elements, which is pretty much the standard for any set subclass. The linked hash set class represents the linked list implementation of the set interface. It contains unique elements and maintains the order of insertion. The sorted set interface is a child of the set interface. It provides an ordering of the elements. The elements of the sorted set are arranged in descending order, which is bottom up. The sorted set interface provides additional methods that allow for the natural ordering of the elements. Tree set class implements the sorted set interface. Like all sets, the tree set class contains only unique elements. Access and retrieval times of tree sets are very fast relative to other set classes, and the elements in the tree sets are sorted in ascending order. So now that we have a brief overview of sets, let's test out some of the set classes. All right, so here in the code, we have our old list of fruits right here. So I'm going to leave this relatively similar, except I'm going to change a few things. So first, I'm going to change this to a set, and then I'm going to change this linked list to a hash set. And of course, we have to import those classes and interface. All right, so I've imported the hash set class as well as the set interface. So here we have our old collection of list of fruits. And remember before we have our output right here. And notice that there were 2 duplicates, one for apple and one for cherry right here. We have our iterator, and we're going to run the program which will iterate over the list of elements in that hash set. Think of what's going to happen after we run the program. All right, so I ran the program and we have our output, but instead of 6 elements appearing in the output, we only get 4. Remember how we had an extra apple and cherry element. So remember that sets remove duplicate elements from the collection. Notice how the order of the elements are different than the way we output them when we utilize the array list and the linked list collections. Hash sets are not sorted in order. If I change this to a linked hash set, for example, and then run the program, we see here that the output order is maintained using a linked hash set. Linked hash sets, like linked lists, maintain the order of insertion. All right, let's play around with the collection class a bit more using some of the other methods that it contains. So first, let's remove all the elements that are in the current collection, and then let's check if the collection is empty. So I did two extra things. So I called the clear method, which will clear the list of elements in that list of fruits collection, as well as I'm calling the isEmpty method, which checks if the list of fruits is empty and returns a boolean of true or false. So let's run that right now. All right, so we see our output right here. We get the result that the list is empty being true. So those are some quick examples of some of the methods that the collection has. There's plenty more that you can do with the collection interface. So just experiment with them, try out different things on your own, and you'll learn a lot more. All right, here's our assignment for this topic. Number 1, in one sentence, give the definition of the collections framework. Number 2, true or false. Sets allow for duplicate values. Number 3, between the array list and the linked list, what is the better collection to use for lists if you want to manipulate an element? Number 4, a hash set has 20 items added to the collection, of which 12 are duplicates. How many elements will be returned from the collection of the hash set? And briefly explain your answer. Number 5, write a program that uses an array list using an integer class of 10 elements and add all the elements together. If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.